Okay, so we start to explain my project. This is basically my health station based on uh, Arduino Q. So we have three Arduino Q. This one Arduino Q number one. This is the number two, and this is the number three. The integration of these three Arduino Q will create a mini cluster because which the main idea is to works into a distributed application. So, for example, the first one, this is the first Arduino Q. It's the master of this mini cluster. Basically, this Arduino has the web page, the communication between the another Arduino, the communication by using I2C to communicate with the different sensors, like analog to digital converters, the electrocardiography model, the phonocardiography using this stethoscope, and using this sensor to acquire the photoplethysmography. So, in the second Arduino Q, we have the electrocardiography classifications, and in the third we have the anomaly detection. So at the same time, this Arduino Q, the first one, it's has the capacity to use the graphical interface, the communication with 3 USB and 1 USB-C, and has the at the same time, but this is the future word, is the integration to this SpO₂ with a metastatic network, because one of my idea in the future it's send the results, send the classification using this network to be using into a place where we don't have a good communication using 5G or another kind of protocols to send the data. So now we start to show you how this works. So we continue. Okay, so we are continuing with the explanation on my project. So first of all, it's necessary to turn off our system. In this case, this is the camera with that I show you my project. So right now, this is the first model. This is the electrocardiography classification models, and this one is the model to detect the anomaly detection. Okay, so this is the main code in my project. This is the README. So now we move to the main Python, and now execute run our project. So you start to run. Okay. Okay, so this is the web page that create to communicate the data that came from the different sensors. So the first, the ADC0 is the ECG, the ADC1 is the photoplethysmography, and the ADC2 is the phonocardiography. So we have these different buttons. So we can select how many times you want to record the data and send the data to this to the another Arduino Q. So because we use a request to send the signals, so now we can click in Start Auto. So this is the data that we are receiving right now, and this is the classification. So the actual at this moment, this model determined that the electrocardiography is a normal, but it's not true. So, but we have an anomaly in our in our anomaly detection, basically because we have in this moment we don't have the electrodes to acquire the electrocardiography. We had not connected in my body, and the phonocardiography didn't receive any heart sound, and the photoplethysmography doesn't work in this moment. So now we start to connect my body to show you how it works. So okay, so now come. Okay, so the first step is necessary to put our electrodes in our body. We need to put 3 electrodes, one in our left arm, one other in our right arm, and the third in our left leg. So now we have connected the system. This is the photoplethysmography. If we can put in my finger, so we can see it in the ADC1, how we start to acquire the photoplethysmography. Okay, so now we're going to connect to acquire my electrocardiography. So we have 3 colors: the green, the red. So the green is here. Okay, so this is my electrocardiography into the ADC0 photoplethysmography, and now we start to speak. Okay, so now we check the results of my test. So now we click on stop, and so I will see that my electrocardiography is normal. And the system detect that has anomaly, basically because it could be because they have a lot of nice signals. So but here we can see the report into the different classification. So anomaly, classification, DSP. So that's all. I hope so that you enjoy with this project. So I need to